All right. So now we're starting with the next section, kind of picking up where we left off yesterday with asynchronous inputs. And the asynchronous inputs have a couple new functions called preset and clear. And they are used to override that clock signal and kind of the inputs that are happening in a synchronized manner, where things kind of have to work in sync and work together. So this is asynchronous because they don't necessarily work together. Preset and clear can kind of override and take effect instantly whenever they are triggered. So preset and clear they're inputs basically, but they are inputs that happen kind of instantly. So in this case, okay, here, I'm going to make a note that preset and clear are active low because of the inverters. Do you see the little circles? Okay. So if we had 5 volts or a logic level 1 coming into here, it inverts and becomes a 0. All right? Which is really, it's kind of receiving the 1 that makes it trigger, but an active 1 out here inverts to a 0. So it's when this becomes a 0 that inverts to a 1, and it kind of triggers that input, the clear or the preset. And so because those inverters, we'd say it's active low. It's actually going to really for our purposes trigger when we have a 0 here. Okay? All right. So what do? The preset input forces the output Q to become a 1. So preset or set is kind of setting the value to a 1. And then obviously not Q is always just the opposite. Clear is kind of like maybe resetting. If you think of kind of going back to low or 0 or no voltage, clear is kind of clearing us and getting us back low. So clear gets the output Q to go low, and then obviously not Q has to be the opposite, 1. All right. So if we fill in this excitation table, preset and clear are active low, so these are not triggered right now when these are 1s. So really, when these are 1s, they're not taking effect, and it's going to act as basically a regular D flip-flop. It's going to, the output is going to change on the rising signal of the clock because there's no inverter on the clock, so it's a positive edge triggered. So when the clock goes high, Q is going to want to match D. So if D is 0, Q is going to become 0. Does that make sense? We'll fill in, though, how about we just fill in the not Qs afterwards? We'll just kind of focus on one thing. All right? And then, very similarly here, preset and clear are not active. The rising edge, if D is 1, then Q is going to want to become a 1. So basically, you could say here, right, preset and clear are, I don't know if you want to make a note, PR and CL are not active, so Q wants to equal D. Need to slide my paper under the camera so I can get a little more in shot. Okay, now, with the next one, it's active low, right? So basically, PR has been triggered. because it's active low. So preset sets Q to become a 1. And these are X'd out because they don't matter. The clock signal, when the preset is triggered, it overrides the clock. It overrides the data. We don't care what's happening. And so Q switches instantly at that point to a 1. And then the other example is clear, triggered low. So CLR is being triggered in this column. And again, so these override, so we don't care. When the clear is triggered, we are making the output go back to 0. And then this one, we have a problem. Preset and clear, both being active low, we're trying to trigger both, which means we're trying to make, preset's trying to make Q become a 1, and the clear is trying to make Q become a 0, and we're like, uh-oh, what do we do, right? And so this one is illegal. You can kind of look at it this way too. In the table, they fill it out as these both being 1s. It's kind of like, well, preset is trying to make the Q become a 1, and clear is trying to make not Q become a 1, right? Clear is trying to make Q 0. So it's trying to make not Q 1. And these cannot be the same thing. They always have to be opposites, right? It's not possible to have them both be 1s, so it's illegal. And out here, I can label this as what we would call the spelling the word asynchronous. I'll abbreviate preset. And this is the asynchronous clear condition. And this is otherwise, right? At this point, it's like a regular D flip-flop in those conditions when they're not triggered. All right. Did I lose anybody? We've added this idea that we've got these flip-flops from yesterday that now have these other two inputs that override the clock and the other input D. So we go try to leave that in the screen. Sorry, this is like the page breaks in this probably need to be fixed for the next time we print these in notebooks. So sorry that the page breaks were not in ideal places for you. All right, so I'm going to draw my little lines again. Just light with pencil to have low and high for Q. And we're going to try to fill in Q, what Q should be based on the clock, the D, presets, and clears, right? So they've already given me these vertical lines at all the rising edges of the clocks. But I'm going to go and add in, look for any places where I should add in another line where the asynchronous inputs have been triggered. And remember, they're active low. So preset and clear are both starting at the 1 level, so they're not active. But right here, preset goes low, it's active low. That's going to be another place that I need to worry about what the output is going to do right there, because it activates, right? Okay. And then clear, looks like that one goes back high, eventually stays high the whole time. Clear gets triggered right here, so that's going to be a spot that I care about. And We don't really know what this was beforehand. I guess we'll just start it right on this line. But on the rising edge of the clock, preset and clear are both disabled, and D is high. It's a 1. So Q wants to match D in this case. Q is equal to D, which is equal to 1. So that's going to go high, and it's going to stay high through the next interval, the next rising edge, unless preset or clear got triggered, but they didn't. So they could override in the middle of that little time interval between rising edges, but they didn't. So Q is good to stay put at 1 for that interval. All right. At the next rising edge, D is now 0. Preset and clear are still not active, and so at that next interval, Q wants to again be equal to D, which is now 0, and so Q drops to 0, goes low. And this is where we're not going to say Q stays low for the next interval, because we see along this next interval that as time starts to pass, boom, right there, that's why I put that line there, preset has been triggered. It's active low, so that low signal, even though we're not at a rising edge, it will override in that instant whatever's happening. So preset wants to make Q go high. So Q is going to jump up to high at that point. Is that okay? So here we've got Q wants to match preset, which is going to make it 1. It's not the preset is 0, but let me do an arrow there, not an equal sign. But Q is going to become a 1. Is that okay? And then it's going to stay there. Even if preset went away, when the preset goes off, it doesn't re-trigger it. It has to, the transition or change of Q is triggered by a rising edge or by the preset or clear being triggered. So they could take that off, and this thing would kind of stay here until the next, like Q would not match D because preset went off. It would only match D on a rising edge. All right, but here's kind of an interesting spot right here. We're to the next rising edge, right? We generally at a rising edge would say Q wants to match D. However, preset is still being kept low, which means at this instant, it's still overriding. So right now, Q is still having to, it's kind of like, hey, preset is overriding D, so I still need Q to be 1. So this is where students kind of think, hey, do I have to do something here? And you don't. With preset getting taken off, it's active. We say it's active low. It is not active high, preset and clear. So when preset goes from being a 0 to a 1, that does not trigger our output. Our output triggers when it goes high to low, but not low to high. So you can think of the preset kind of being taken off. Q does not respond. It's just now we're putting Q back in a state that the next time the clock triggers that it can match D, right? Where it kind of this whole time it couldn't match D, it had to match the preset, it had to be 1. So we're still going to extend this to here. Okay, because, right, preset's not being triggered, clear is not being triggered, so at this point on the next rising edge, Q is going to match D, and D is 0, so it's going to go low. All right, how are we doing? Let me kind of pause and look around. Are you guys with me? Mentally? We're good? Everybody's good? Who? Reese, not Rice, right? All right, hopefully we can finish this last little part in the next few minutes because it's almost lunchtime. All right, so now we're cruising on this next interval. Here's the next rising edge. In that next interval, both preset and clear have not been triggered, so we're good to stay at that 0 to the next interval, to right there. And then at that interval, preset and clear are not triggered, so right here at the rising edge, we'd say Q wants to match D. And what is D? D is 1, so this wants to come up to a 1. And then it's going to be there for the next interval unless preset or clear are triggered, and they are. So I'm going to kind of pause right there and evaluate. So when clear is active low, right, went low, clear, Q has to worry about clear, and clear makes our output go 0. So it's going to come right back down to 0. And then, even though the clear comes off right here, that's not going to trigger Q, so Q is going to stay low until the next rising edge of the clock. Is that okay? And then on the next rising edge, preset and clear are both off, so now Q is freed up to match D again, and what is D? D is now 1, or still 1, but so now Q can go back to 1. And preset and clear are not triggered in the next interval, so that 1 is going to be all the way through to the next rising edge of the clock right here. Preset and clear are not triggered, so again we'll say Q is going to match D, and D is now at this point in time 0. And so it'll go back to 0 and kind of continue on. We can't see past that. So there you go. This is an asynchronous flip-flop, so we've added in the preset and clear functions, which are override functions, to override a 0 or override a 1 exactly when and where we want it. Because without those, we were stuck waiting for the clock signal, right? Which there's some measurable amount of time. What if we wanted to create a circuit that didn't have to wait for the frequency of the clock to trigger? We want it exactly in that instant, in that millisecond or microsecond to trigger something, right? So maybe you think of the analogy of our CO2 cars crossing that finish line. We don't want that to trigger something and then have to wait for a clock signal to record that the car. We want in the very exact instant that the car triggers to record that change, right? So there are applications where we want to trigger instantly. All right, we're going to pause it there. It is time for lunch. All right, so I think we didn't really have time to answer questions. Did you guys have questions before you ran off to lunch on that? You feel good on it? Everybody feel okay? Good? Okay, so the next thing is a latch. So this example is a D latch, so it's like the D flip-flop, but they've replaced the clock. They've still got the Q and not Q and the D, but they've replaced the clock with this EN, stands for enable. And the big difference is, we'll just kind of fill in this down on the bottom. The flip-flop with the clock input is, we're going to say edge sensitive. The flip-flop was going to update and change its output on a rising or falling edge of the clock, right? The latch, though, it is not going to look at an edge. It is going to look at the level of the enable. Is the enable 0 or 1? We say it's level sensitive. So they've already filled in this excitation table, and they've showed when enable is off, so when it's 0, there's no inverter there. So in this case, the enable, this example, we're going to say that EN is active high. Okay, so the enable is kind of turned off. then if it's not enabled, then what D is doesn't matter. Okay? Q is going to stay Q. So they've got the Q sub O like the original Q. But if the enable is enabled, then Q will match D. So if D is 0, Q is 0. If enabled again, if D is 1, Q is 1. Okay, so we'll try to fill this in. Make sense of this over time. All right, so you guys do get that this is a left to right graph showing signals that are changing over a period of time, right? So we kind of have an x-axis here of time. All right, so the enabled is off, it's low. So I don't know where Q would have started, whatever it would have been off, but it wouldn't be matching necessarily D. So let's just assume that it started low. Okay, so as long as this enable is off, Q is going to stay the same. Okay, so D changed, but Q is not going to change. And now normally we think about, oh, it's the rising edge. No, it can change as long as we're enabled. So enable is 1, so this is kind of, this section is enabled. And then this would be like disabled. It's like we've disabled the ability for Q to match D, but when it's enabled, Q is going to match D. All right? So, D is 1 right there. So guess what? Q is going to become 1. And it's now, as long as we're enabled, Q is going to be able to actively and kind of simultaneously model or match D. So while D is 1, Q is going to be 1. But when D goes down, at the same time, Q is going to go down. Does that make sense? And then D is low, so Q is going to stay low until right here. And D went high, we're still enabled, right? The enable button input is still at a 1, we're still enabled. So we're going to follow D to right there. And then at this point, something happens, right? The enable drops to 0. So once that happens, doesn't matter what D is, Q wants to stay what it was. So through this entire period, we don't care at all what's happening here. Right at this instant, Q is just going to kind of lock in. Doesn't matter what kind of squigglies, ups and downs happen there. It's all ignored. 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 Make sense? I'll do that very lightly in pencil. All right. Once the enable triggers again, boom, this whole range in here, once we're enabled, Q is going to match D. So, D is high, so we're going to stay high until, right? Basically, all these little changes to D, as long as we're enabled, we're going to follow them. So we're going to drop low like D does, stay low until D goes high. We're going to go back high. We're going to stay high until D goes down. We're going to follow D because we're still enabled. And boom, right there, the enable turned off, right? So once the enable's turned off, we're kind of stuck where we're at until the enable would reactivate. So we were low when the enable went off, so we're just stuck low, basically. And then once we re-enable, we're free to match again. And now D is 1 there, 0 there, so we're going to shoot up to 1 because we've got to match D. So we weren't with D yet, so at that instant we're going to try to match D, go up to 1, and then follow D. D goes down right here to 0, and that's the end of our sample graph. So that's a latch. And that is the end of your notes.